So before I talk about the architecture, I'd like to show this slide that basically is from a popular data science paper that talks about the reality of building an end-to-end machine learning system. What you see in the center, the black box in the center, is actually the machine learning code. And all the other surrounding pieces that you need are the infrastructure that you need to have a successful end-to-end use case in production. We can divide this into two phases: the model building part, which is the actual model training and the model development. And then on the right is the model serving piece, which is deploying your models and invoking your models and getting predictions or outputs from your model. What model as a service in our talk we are going to present is the right-hand side, which is the model serving piece of it. Once a data scientist is done building the model, we need to validate it, version it, audit and distribute it. There's a need for infrastructure to host your models and a way to interact with them. You also need all the necessary tooling like monitoring, logging, robust CI/CD. You want to have resiliency, be active. All of these in order to have a successful use case. You also want to have, another challenge is identifying these errors. How do you identify failures in the model and how easy it is to roll back? You also want to have governance and risk management. But based on empathy research from data scientists, what we saw was we want to make the first and foremost thing is to make machine learning deployments portable. By portable, what we mean is take a model from a data scientist's local development environment to staging and all the way to production with all the controls in place. So given these factors in mind, we wanted to go with a service-based approach so that we can start building from ground up. Focus on the core pieces and then start adding those features in. The boxes in red, what you see, this is an example architecture, is the model as a service architecture. The surrounding pieces that you see, the yellow boxes are the complementing pieces, but what we talked about, like having the model features as a service, rules as a service, and metadata registry. Ideally, what happens, the data scientists would first version and store their machine learning models in a repository and then invoke a service that would help them to take a model all the way through the control gates and put them into production. So there's a model deployment service that's listening and capturing your metadata, and after your model is ready to be served, the box in the center is the model serving piece. I'll talk about that in the next slide. And then you want to interact with the model. So we have this model routing service that basically takes in the features and the values that you want to invoke your model and also interact with other components that we have, the rules of the service and the feature of the service. For example, given this transaction that comes in, pull in additional features from my feature set, fire the model, give me a score or output, and then I want to decide what rule or action to take. And last but not least, you want to collect all these metrics for feedback and monitoring, so you would push all the data to your proprietary database or any other analytics tools. The box at the top of the center is the model serving piece. This is the most important piece of the technology we're using. We're using a technology called Celdin. It's built natively on Kubernetes. We chose Kubernetes because it's very well handles container orchestration and gives us a lot of other benefits for resiliency. These are the high-level steps that we ideally need to deploy a model. It basically takes a model, containerizes it, takes a source code or an artifact, containerizes it and deploys it to Kubernetes cluster. And then gives you endpoints in terms of like REST and gRPC-based endpoints that you can use to invoke your model. Hence, it gives you the decoupling aspect for your model execution. In addition, Celdin not only does single model deployments, it also has other features like you can deploy multiple models and do A/B testing on them, do multi-hop bandits. You can also have combiners where you can combine the outputs from several other models and determine a common score that you want to do. And also transformers where you want to transform your input and output in certain formats. I'll move on to the model deployment service. This is again an example architecture using Kubernetes components to deploy our model. It essentially takes in a model manifest file from the publisher, packages the model, and deploys into Kubernetes cluster. I won't go into details, but essentially what it does is it uses the components of Kubernetes like ingress, packages the models into containers, which is inside pods, and host it as services which are ready to be executed. And also using other services like authentication and other services that you want to build. And eventually all hosted in a cloud provider, so you can have all the benefits like resiliency, blue-green deployments, and isolation of your models. This is the experience what a data scientist would do. First, he would prepare his model repository. In this example, we have an H2O model that he's serialized and kept it there, and also a test or CSV. This is basically needed when you want to execute a model, and after your model is deployed, you want to make sure your model execution worked perfectly or not. Second point is you deploy this, you prepare the model manifest file. Basically, it tells where your model is located, what's the model name, the version, what model type it is, and any additional model requirements. For example, you want any dependencies to be injected in your container, and then the labels are basically additional metadata information that you want to tie to your model for discovery. Next, you would invoke this microservice using post API command to deploy a model. You get a 201 response, which is asynchronous response. Your model is in the process of being deployed. What happens in the background is a CI/CD process that runs. This is an example. You want to have be well managed. You want to make sure there's static analysis, security code scan. You package and deploy a model, and after you deploy a model, you want to test your endpoint with the data that the data scientist provided. After it's deployed, that it functionally work, and it's going to capture the output and send you an email response back or a Slack message. Your model is ready to be served. This is an example notification saying if your model is actually deployed or not, and an email notification also would get sent out. And in that notification, we're also attaching like an output that basically says the input that you provided, your model execution ran perfectly, and this is the model scores that it produced. That basically closes the loop and gives you the confidence level in your CI/CD pipeline. The model routing service is essentially, again, this is used by consumers who want to consume a model. It would hit an endpoint, again using Kubernetes components. Your model routing service essentially does not only wraps the underlying technology, what we're using, but also does additional features like you want to integrate with rules of service or feature of service, and also want to do additional routing capabilities with Champion Challenger. So essentially what happens is it exposes your model as REST endpoints, and that can be consumed by use case. This is an example for REST and gRPC invocation. You pass in the features and model values, get an output, and you can consume it. And similarly, if you want to have if you have high streaming applications, definitely there's a choice you can make to go with gRPC protocol. So with model testing is, we looked into everything what data scientists need. You wanted a utility to test your models offline. So you want to also provide some additional analysis and you testing utilities. For example, a Python-based module where you can install in your local in your console or your Python notebook and invoke your model, and it would basically convert your CSV data or JSON data into the payload that the model expects and return you the response out. So we also have support for like data frames. For example, we've seen some data scientists like they use data frames instead of CSV. So giving them that additional capabilities in your model execution would definitely help. And having that integration directly in your notebook was a big plus. So with that, I just want to hand it out to Neeraj. He'll continue the rest of it.